Here's a quick video on collecting like terms. So just give you a quick rundown on just the basics, like I explained at the top of this page. But yeah, essentially it's this. So we've got a bunch of numbers and variables. We call them terms and separated by plus and minus signs, and we're just trying to collect things that are the same. So let's say we had 3x plus 2 minus 2x plus 5. So there's a whole bunch of stuff. And why do we have things separated that are like terms? Who knows? So we should collect them. So pretty much anything that's a like term are things that have the same variable and exponent. And as long as they fulfill that, they're like terms. So for example, a set of like terms would be 3x and 4x because they both just have x's. Another set of like terms would be like 3y and just plain old y. Those are like terms because they both have the same variable. Things that wouldn't be like terms would be 3x and 2x squared. Because, that's just an x to the power of 1, and this is an x squared, so these guys are not like terms. So they have to have the same variable and exponent. Also, constants are like terms. So that's just like numbers on their own. So if you have like a c, apparently, is a number. Sorry, so if you had like a 4 and a 7, those are like terms because they're just numbers. They don't have variables. So if we were going to collect these like terms in this expression, we would just do it by identifying them. So we've got a 3x and we've got this negative 2x. The sign in front of the term always stays with it. So that guy stays with the 2x. That way we know what operation to do. So 3x take away 2x would give us just a single x. You don't need to put the 1 in front of that. Just assume it's there. And then looks like we just have our constants left. So we have a positive 2 and a positive 5. So if we collect those things, 2 plus 5 is 7. And since it's a positive 7, we'll put plus 7. And that would be it. Now we've collected all our like terms. We've kind of simplified the expression, which is nice. Why would we have it all separated? Doesn't make sense. Okay. So let's just try another one, and then I'll show you how to do this using Alg Tiles. Okay, so say we had 4x squared minus 4x plus 2x squared plus 9x minus x squared. Okay, there's our crazy expression. So I'm just going to group my like terms together. I like to start with the biggest exponent first, just because it seems like more of a proper way to write things. So we've got a 4x squared. Now I'm going to search for all my x squared terms. So I've got this positive 2x squared, and I've also got this negative 1x squared. So I'm going to group those all together. So I've essentially got a 4 plus 2, which is 6, take away 1, which is 5. So I've got 5x squared, guys. I'm going to move on to my x's. So here I've got negative 4x and a positive 9x. So if I group those together, negative 4 plus 9 is positive 5x. And there we go. I've collected my like terms. I can't collect these though because they have different exponents, so they're not like terms. So that's how you do that. And then I gave you guys a worksheet in the next page that's uses Alg Tiles, which you're not required to do, but sometimes people like things that are more visual. So if you are one of those people, Alg Tiles are manipulatives, and you could probably get them from your math department at school if they've got them. And they look like just basically tiles. And x, you can represent like positive and negative numbers and x terms and x squared terms. So I'll just show you. So they're called Alg Tiles. So if you're someone that's like, ooh, I like working with my hands, manipulatives, that works for me, see if your math department can get you some. So typically you'll use 2 colors. So I'm going to use blue to represent positive numbers, and I'm going to use red to represent negative numbers. And I'm just going to use black here because I'm not talking about positive and negatives, but just the shapes of the tiles. So little square tiles represent ones. So like 1. So if I wanted to represent the number 7, I would just write 7 square tiles. Okay, that's taking a long time, but you know what I mean. And then if I wanted to represent x's, I would use this long rectangular tile. So that would represent like 1x tile. And if I wanted to represent an x squared term, well, technically that's like an x times an x. So that's going to end up being like a giant square. So it's like the same length as the x term, like this, but times itself. So hence the side lengths. It's like the side lengths are x and x. So x times x is x squared. So that's how it gets its shape. So those are just the only tiles we'll work with. And then if the color of them is red, it's negative, and if the color is blue, it's positive. So let's say I wanted to represent the expression. Let's just practice representing an expression. So say you had 2x plus 3. If I wanted to represent that using algetiles, okay, I need 2 x's, and they're positive, so I'm going to use 2 blue tiles. So like this, there's 1 x, but I have 2 of them. So there's 2. And then I need 3 1 tiles, and they're positive also, so then I would just use these 3 tiles. And that would represent that expression using algetiles or algebra tiles, what do you call them? So that's how you would represent them. And then if you wanted to actually solve a question using them, like a like terms problem, let's just try, let me just demo that for you. So say you had 3x plus 1 minus 4x plus 2. Okay, so there's your expression, and we're going to first represent all those terms using algetiles, and then we're going to see what cancels out with what. Okay, so first I want to represent my 3x. So I need 3 x's, and they're positive. So I need 3 blue tiles that are skinny rectangles. So 1, 2, 3. I'm sorry that the size is changing constantly. And then I need a positive 1 tile. I'll just create that. And then I need 4 more x tiles, but it looks like they're going to be negative because that minus in front of the 4x. So I need 4 red x tiles. So I got 1, 2, 3, 4, and then I got a positive 2. So I'm going back to blue, and I need 2 square tiles. Okay, so I just represented the scenario here. And then we all know that, well, hopefully we do, if you had a positive and a negative of the same value, they're going to equal out to 0. So let's say we had a positive 2 and a negative 2. We know plus 2 minus 2 is going to equal nothing, 0. If we had positive x, take away x, that's going to do the same thing. So we're using that principle to cancel out algetiles and collect like terms. So looks like the blue is positive and the red is negative, so they'll cancel each other out. So this tile right here, this blue guy and this red guy are gonna pretty much go away because it's like 1 minus 1, really, or x minus x. So they're gone. I got another match, they're gonna go, and another match, they're gonna go. So all I'm left with is 1 red x tile, and we know that red is negative, so all I'm left with is a negative x tile. Then if I look at my blue tiles, I've got 3 of them all together, 1, 2, 3, and they're all blue. So I got positive 3. So I just used algetiles to simplify this expression. Yeah. So you can do that if you want, or not. You can just do it by hand, whichever one you like better. But I have a interactive practice thing you can do with algetiles if you prefer those. And a whole worksheet that involves QR codes to check your answer with algetiles. So good luck, and I hope you find a method that works for you.